Today's lesson 10 and 11, we're going to be talking about predicting thunderstorms and tornadoes, looking at some pictures about and understanding how tornadoes form. When we think about weathermen and women, meteorologists who predict thunderstorms, um, what do they use? Well, they use a map called the K-index map like this and a lifted index map like this. Well, they combine those two, and what the K-index map does is it shows the best chance of thunderstorms. What it does is it looks at the temperature at the ground and the amount of humidity in the air. Remember, some of the requirements are, for thunderstorms or low cold fronts coming through, is cold air running into warm air, cold dry air running into warm moist air. Well, if you know the ground temperatures and the amount of humidity in the air, if there's a lot more humidity and the temperatures are different between the high temperatures and low temperatures, you're going to have a better chance for thunderstorms. Then they do the same thing on the lifted index map, but they use that same information but higher up in the atmosphere. Well, when you combine both of those, you get a map that kind of combines this K-index, which kind of says, okay, this area obviously and this red area right here, they must have lots of moisture in the air and lots of differences between the cold air and the warm air down below, the cold air up above in the atmosphere. So like where we are right here, we would be at a 85% chance of thunderstorms. But up here in northern Minnesota, it doesn't look like there's any chance, or down in Florida, there's very little chance. This is a spot right here, however, in Utah that I probably would not want to be at. This lifted index map also kind of shows a different time period, a different day, where the potential damage or storms could be because of the higher elevation temperatures and humidity levels. Down here out in the Gulf of Mexico, that looks probably like the worst place to be, but we could fall into that category of it being probable. Now, with this animation, I think it's here, you can kind of see how these thunderstorms pop up throughout the day. You can see right down here, little clouds build up, and then bam, it just blows up into big, huge thunderstorms, and some more pop back here and some more pop over here. And they use all that energy in the atmosphere, and then by 7 o'clock at night, it's all kind of gone away. So you can kind of see how, in the morning, everything looks fine, clouds kind of build up, must be the heat of the day building up, and all these clouds just start to form. The thunderstorms blow up all over the place, and then by the end of the day, they're gone. See how quickly that can happen. Now, as far as number of days that we have across the country for thunderstorm days, here we are right down here. We're somewhere between 30 and 40 days a year that we actually have thunderstorms. Well, there are some areas out here that said it's 70. Alaska has 1 day a year. A couple of places inside, maybe 5 or 6, 100 thunderstorms a year in Florida. That's 1/3 of the days. If you look at this map, we do definitely can label this as a front. High pressure, remember, has very little clouds, so I mean that could be a high pressure area. Low pressure area probably down in here, and again, this is still part of that same front way up in here. As far as tornadoes go, there's an animation right down here. Not the thunderstorm. Let's move on to the next lesson. It's this one right here. If you click on this, or I'll click on this for you, but you can kind of see the same process. Big clouds. We must have a cold front coming in, pushing all these clouds real high up in the atmosphere, running into warm air. And then with the big difference between the upper air and the lower air in temperature and humidity, you can create this tornado that runs through and wreaks havoc. But what are the steps? It's the same thing as a thunderstorm. Cold air runs into warm air. Warm air gets pushed up really fast. That pushing up a really fast warm air cools it, makes more clouds, creates thunderstorms. Well, then once we get that thunderstorm rolling, it's that big difference between the cold air and the warm air. The warm air is pushing up and it's trying to get through a cold area in the atmosphere. And if it can punch a hole through that cold layer, then that difference between the cold and the warm, it kind of acts like a reverse drain, and the wind starts to spin up, kind of like water would spin down a drain, but it's spinning upwards. A couple things about tornadoes: they're rotating columns of air. They can blow as fast as 100 to 200 miles per hour. They form when cool, dry air meets warm, humid air along a cold front. They make these clouds that are 50,000 feet tall. This picture I want to just show you, it's faked. Sometimes you see pictures. This guy's a fake picture. But these guys are real. And tornadoes can come in lots of different forms. They come from these things called supercells. They're huge thunderstorms. And these thunderstorms have these up and down drafts that carry hailstones up. If you're ever in an area where it's producing rain and large hail, you're potentially in an area where we could be looking at a tornado forming. Some of these pictures that you'll see right here, this is an older picture, but these tornadoes can move 70 miles per hour on the ground. Usually they don't last about 10 minutes on the ground, but the damage that they do is crazy. If you look, here's what's left of a house. There were houses on these slabs out here, but now they're not there anymore. How they form or why they form, well, the Midwest is a pretty common place for it to happen, because we get all that cold air coming down from Canada and the warm air coming up from the Gulf of Mexico. When they meet in the middle of the United States, and the storm circulation produces tornadoes. Now, every state in the country has had a tornado before, so no state is free of tornadoes. This picture right here is coming from Wheatland, which is nearby. I think I have some other pictures as well. Here's a picture right here of damage that happened from the Wheatland tornado back, I think, in 2007. A house is no longer there. There's this one right here. If you look at this picture, only the concrete basement is left from this one. So damage is crazy. Here's a house, or was a house, and what's left over, you can see a tree just got snapped off right at the root. Lots of damage can happen from tornadoes, and you really have to be careful about these guys. When they start to threaten, the weathermen start to say, look out for tornadoes, you really do. Now, this tornado alley is kind of an area that has been hit most often, because they really are in a spot between all the warm, moist air from the Gulf of Mexico and the cold air from Canada. And when they meet, this is where things happen, and we kind of happen to be in that part right there. Now, tornadoes themselves are scaled on this Fujita scale, an F0 being a very small tornado, 65 to 85 mile per hour winds, all the way up to an F5 tornado, which is 200 mile per hour winds, which they say, description of that is houses are leveled, nothing left. Automobile-sized missiles fly through the air. Things as big as cars get thrown over 100 yards away. Trees are debarked. The actual bark of the tree is ripped right off the tree. So, and then everything else is kind of falls in between. I think the Wheatland one was an F2 or an F1, I think, maybe an F2. So tornadoes are pretty serious things. Take some time to look at this chart right here. Remember that we are going to start to do our lessons, our weather broadcast starting tomorrow. So good luck. Any questions, just send me an email or just ask me in class. Thanks.